Three of the most common communication methods used in industrial automation are Discrete, Modbus, and I/O-Link. In this video, we'll talk about each technology and what purposes they serve. Discrete refers to systems that operate on isolated applications and function as simple on-off signals. Modbus is a protocol that is used in industrial automation systems via serial or Ethernet communication. I/O-Link is a bidirectional, point-to-point industrial networking standard that is known as IEC 61131-9. It's used to connect digital sensors and actuators to an industrial field bus or Ethernet application. Let's go deeper on these types of technologies and explore how they work in different situations. Discrete technology occupies a unique area between solid-state physics, analog behavior, and digital logic. This offers a direct view of how electron flow is transformed into abstract computation. Before using integrated circuits, computers were made with discrete components. Even a single logic gate would use multiple components and would require additional board space. As a learning tool, signal paths can be physically traced with current flow for things like amplification, biasing, and feedback. This not only shows what the circuit does, but why it behaves in this manner. While ICs are more common in modern electronics, discrete components remain in high-power systems, RF and microwave circuits, and radiation-tolerant space and military applications. Modbus is a protocol that is used over different communications, including RS-232, RS-485, and TCP/IP. Its longevity comes from the ease of debugging and is easy to implement due to being small and well-documented. Almost every PLC, HMI, SCADA system, and industrial gateway supports this protocol. One device in an application speaks at a time, which can simplify timing analysis and fault diagnosis. Modbus supports broadcast commands that are issued by all devices without responses. This is useful for tasks like synchronizing devices or issuing commands. But be cautious, as an unintended broadcast can affect every connected device with no error feedback. In Modbus RTU, message framing relies on silent gaps in communication rather than explicit markers, which makes the timing very critical. I/O-Link operates under major industrial networks such as Profinet, Ethernet IP, EtherCAT, Profibus, and Modbus TCP, with the I/O-Link master acting as a translator between field devices and the control system. This bidirectional communication enables remote configuration, faster commissioning, and required maintenance prediction. Each device has a dedicated point-to-point connection to the I/O-Link master, which simplifies wiring, improves fault isolation, and makes troubleshooting easier in identifying which device has an issue. Configuration is standardized through the I/O device description IODD files. These define device parameters and data formats, enable supplier-specific integration, and allow clear visuals and setup in engineering tools. An IODD acts like a driver in a computer system, making sure that the control software understands how to communicate and configure the device correctly. Discrete pros and cons. Discrete pros include being suitable for applications that prioritize speed and low cost. Being a simplified solution having specific components rather than highly integrated systems, making it easier to troubleshoot with a multimeter. Discrete solutions are limited to on-off data and cannot represent variable or analog signals. Each signal requires its own wiring path, which causes panel space and cabling to increase as the system grows. There is a maximum of 15 wiring configurations. Troubleshooting can be time-consuming and requires manual labor. System modifications or upgrades require physical rewiring, leading to increased downtime, labor costs, and reduced flexibility. Modbus pros and cons. Modbus is a low-cost communication protocol that is widely used for connecting field devices such as PLCs and sensors, and for integrating older existing equipment into newer automation and data systems. It is also great for applications required for longer distances. This type of technology supports daisy chaining without the need for additional components. Modbus uses a very limited register-based data model with no built-in device descriptions or diagnostics. Performance is relatively slow, especially in larger systems. Manual mapping is required between devices and control systems. Registers must be documented to maintain long-term reliability. Lacks built-in encryption, which raises a concern for safety on cyber attacks. I/O Link pros and cons. I/O Link turns sensors and actuators into smart devices by providing continuous diagnostics, device identification, and remote parameterization. This reduces troubleshooting time, prevents unplanned downtime, and simplifies the maintenance in applications. Provides a simplified wiring solution using only 3 wires and M12 connections. The I/O Link Master will automatically save the previous setting for the new replacement device. Some cons include devices and masters typically cost more than standard I/O. Not meant for high-speed control due to slower cycle times. Each device requires its own port on an I/O Link Master, which also means it does not support multi-drop networking and can't be daisy-chained. It requires familiarity with device descriptors, IODDs, which can add complexity and increase setup time for users who are new to the technology. The cable connection is limited to 20 meters, which affects the distance that each module can be placed.